Hi everybody, today we're going to talk about inverse trig functions, what they are and how you work with them. So for starters, an inverse trig function, if you have like y equals sine of 30 degrees, and we saw it in an earlier video, that was a half. An inverse trig function might look like this. Sometimes you see arc sine of x, and sometimes you see sine with a little -1 of x. These are the same thing. That is confusing. I don't know why they have two different notations, but they are. So those are the same thing. Also, this -1 is not an exponent. It is a little inverse sign. Another mistake people make is they think that's sine to the -1. That's false. It just means inverse sine. On the calculator, if you ever look at your calculator, you have this little sine -1. That is the inverse sine, arc sine. Same for arc, cosine, and tangent, and anyway. So the way this works is, if you recall, for example, the sine of 30 degrees is 1/2. You might be asked, what is the arc sine of 1/2? Or what is the inverse sine of 1/2? And the simple answer for now is 30 degrees. There's a little more to it that I'll get into, but the inverse trig function is a question. What angle would go into blank trig function, sine, cosine, whatever, to give me this number? What angle goes into sine to give me that would give me a half? So it's 30 degrees. That's just the very basics of an inverse trig function. Let's try one more time. From an earlier video, I told you that you had this chart where 0, 30, 45, 60, 90. Sine of 0 is root 0 over 2, then root 1 over 2, root 2 over 2 at 45 degrees, root 3 over 2 at 90, root 4 over 2, and then cosine is the opposite. So that's something we talked about earlier. Say we did inverse cosine of 45 degrees. Let's write that down. Cosine inverse, say you do square root 2 over 2. That would be 45 degrees. I'm going to say, or pi over 4 radians. Because what cosine gives me root 2 over 2, what angle goes into cosine and give me root 2 over 2? Well, it's either 45 degrees or pi over 4. We know that from my table right here. Here's cosine. Here's 45 degrees. It comes to pi root 2 over 2. Think of the inverse trig functions as just undoing a normal trig function. It's the exact opposite. Instead of you give me an angle, I give you a number. Now they give me a number, I give them an angle. A little bit more to kind of dish out here, but we've kind of got the idea. Going back to the arc cosine of 45 degrees, or also the inverse cosine of 45 degrees, I'm saying them both because they're the same. I want you to just remember they're the same. It turns out that there are there can be more than one answer here. I'm sorry, I wrote down 45 degrees. I had that in mind. Sorry, root 2 over 2. Inverse cosine, root 2 over 2. Okay, turns out there's more than one answer here. And that's because to get positive root 2 over 2, there's two places cosine is positive. It's in the first quadrant where cosine is positive, also in the second quadrant. X and cosine go together, so x is positive on the right. And root 2 over 2 goes with 45 degrees. So that would be my reference angle in quadrants 1 and 4. So I'm going to draw that. There's 45. There's 45. Quadrants 1, quadrants 4. So one answer is 45, definitely. The other answer is all the way around here. This is 360. So if you back 45 off of 360, the other answer is 315. So again, the inverse cosine of root 2 over 2, in English, that means what angle could I put into cosine to give me root 2 over 2? That's 45. That's 315. Let's try one more. I'm going to say inverse tan of negative root 3 or arctan of negative root 3. What does that equal to? Two answers for us here. We need to go to my chart. When is tangent negative? Well, that happens in the second quadrant, also in the fourth quadrant. So I know I've got two answers, one in the second, one in the fourth quadrant. For root 3, in my table, tangent was root 3 at 60 degrees right here. 60 degrees. So the 60 is my reference angle. We're going to be in quadrants 2 and 4. So here's 60. There's 60. This is quadrant 2. That's 180, 90, so forth. So this angle is 60 back from 180, so that's 120. And then this angle is 300. And if you wanted this in radians, we could easily convert to radians by just doing my trick. Divide by 180, slap a pi on there. So 120 over 180 reduces by 60s to 2/3 pi. So this is 2/3 pi in radians. And then the 300, again, divide it by 180, slap a pi on there. Reduce this by 60, so that's going to be 5 over 3 pi. So 5 over 3 pi radians. If you need radians or you need degrees, doesn't matter. It's a different language for the exact same thing. I hope this helps you get started with inverse trig functions. Come back. I've got a lot of videos. I'm making a lot of videos, and I love your comments to know what you need to see next. Have a great day. Bye-bye.